Hi, everybody, and welcome back to the Pacific Science Center. We are live at the Curiosity Studios, all ready for our PreK Virtual Field Trip program. My name is Michael Sims. I'm an educator here at PacSci, and I am so excited that you all got a chance to participate with us today. Before we get started with our exciting activities, there are just a few housekeeping things I think will be great to help us share, explore, and have fun. The first thing I really need to make sure that you have with you is make sure that there's an adult friend in the room, someone that could help you chat or ask questions, help you participate in this program. I love asking questions, and I want to make sure you have an opportunity to ask me questions as well. You could do that with your adult friend in the chat. My friend Zita Strickland, she's another educator at PacSci. She could also help facilitate those great conversations and really enhance your curiosity. When you're on chat, just be respectful, watch those screen names, but let's share those ideas and those experiences together and those observations together. Another thing I want to make sure that you have today is I would like to make sure you have some room. So if you're sitting down at the computer, make sure that you have a chance today to kind of step aside, stand up, and get ready to move during this activity. So make sure that you have some space that you could do that safely, okay? And then finally, I want to make sure that everyone helps us participate by taking a survey and help inform us about this program that we are offering to the broader community. This program is scheduled for 30 minutes, but it's kind of a prototype. So thank you for helping us test this activity in the curriculum. So if we go over 30 minutes, that's okay. That means there's more curiosity to explore. With that in mind, I think it is time to get started on today's big idea. And what I want to share with you today is all about space. Space is a fantastic thing. Everything in the universe is inside of space. It includes everything, including the sun. We have other amazing things like the moon we can see out in space at nighttime. Oh, look at that. That's a nebula. That's a huge cloud out in space. Sometimes that's where baby stars are born, or sometimes that's a sign that a star has, there was a massive explosion. And what else? Oh my goodness. You know, I thought there were a lot of stars when I looked at the sky last night, but man, oh man, these are not stars. These are galaxies. Galaxies contain hundreds of millions of stars, each of them themselves. Oh, wow. It's almost like we have an entire universe out in space. This is amazing. What a great topic to look at today. Oh, and then there's the planets, of course. There's Mercury, Venus, Earth, Mars, Jupiter, Saturn, Neptune, Uranus, and Neptune. This is amazing. There's so many things out in space. A lot of them you could actually see tonight in the nighttime sky. Oh, wow. Space is so fantastic. I'm not even sure where to get started. There's just so much to talk about. Let's see here. Let's get started with the biggest thing in our solar system. It's so big and so massive. It really lights my world. There it is. Do you all see that special star that we see during the daytime? Even during the daytime with all the clouds in the sky, there is one very special star that we can see at night, or during the daytime. And that is this special star right here. It's a nice glow. It's our sun. It's the star that we can see during our daytime. But this is a view of the sun from the Earth. I'm wondering what it would look like out in space. Does anybody have any suggestions or ideas of what you think the sun, a star that's out in space, might look like if we traveled out to space? I think we should go ahead and blast off and see if we can see it. Oh, wow, friends, look at this. This is a view of the sun from outer space. It was taken by some astronaut friends all the way at the International Space Station. This is what the sun looks like all above planet Earth. Planet Earth, that's That's where you live. That's your home. And you know what? It's so bright and so bright, and there's so much light. I really can't make out what it is that we're actually seeing. Well, there's a good picture of the sun. This picture was taken by a robot that NASA has sent to the sun to really give us a good sense of what it looks like on its surface. But you know what's weird about the sun? Well, I can see it during the daytime, but I can't see it during the nighttime. That's weird. I thought like that's when stars come out. Stars come out during the nighttime. Why can't I see the sun during the daytime? Do you have any ideas or any suggestions, any observations? Go ahead and post them on the chat, okay? In the meantime, I think in order to answer this really big question, we're gonna have to need the Earth. That's your home, that's where you live. And so let's go ahead and do what scientists do and see if we can make a model of why it is that we can't see the sun during the night, but we can see it during the day. For this, I'm gonna need a model. I'm gonna need, well, this is a model. It's a globe. It is a big sphere of what planet Earth looks like. Imagine you took this giant planet that you live on, spinning in the wrong direction, and shrunk it down into a big, small ball that we could see the entirety of the Earth. So that's one part of the equations. The other part, well, let me think my question. My question was about, it was about the sun. So of course, we're gonna need a picture of the sun. And these are two things that we're gonna have in our model. But while this picture of the sun is really, really nice, it's not shining the light that I need for my model. So I'm going to go ahead and use this flashlight right here and turn it on. I'm gonna put the sun right there so that I remember that that's where the sun is. And you can already see that flashlight, that light coming from the sun. It's hitting my face, isn't it? But it's not hitting the other side of my face. So it's light here and dark over here. I think this might be helping us with our clue. Let's go ahead and add that other element. Let's add the Earth to our model. As you can see, we got light on this side of the Earth, but no light on this side of the Earth. So it must be dark over here. I wonder how we get this side of the Earth to get light. Well, I can't move it this way. Can't move it closer to the light. I can't move it farther to the light. Friends, I could spin it. Look, if I spin the Earth, then this part of the Earth will spin all the way around until it's light time. You know what? That was kind of hard to see. I think I need to add to my model a little bit. So do you see North America right here? I'm going to add a friend to North America. In fact, I'm going to add it right where Seattle is. Do you see this red pen? Well, it's a red pen, and let's just go ahead and call it Elmo. We'll put Elmo right there. And then on the other side of the Earth, where I can't see Elmo anymore, I'm going to put a yellow pen. This is going to be Big Bird. And let's go ahead and put Big Bird right on India. So I can't see that red pen. I can't see Elmo, but if I spin the Earth, well, now I can see Elmo, but I can't see Big Bird. Let's see if this spinning really helps us with day versus night. So I got this bright light, and friends, let's just move things a little bit closer. And we just dropped our sun, and that's okay. We have that bright light shining a big light on Elmo, that red pen. But the Earth is going to spin around and spin around. Now the light is on the yellow pen, but it's not on Elmo. Let's try that again. Let's keep on spinning it. Now the light's not on either one of them. Oh, now the light's on Elmo. Oh, shoot, it's dark on Big Bird. Let's go ahead and try that again. Well, no, now it's dark on Elmo. Well, no, now it's dark on Big Bird. Friends, that's what causes day into night. The Earth rotates, it spins. Now it's time for you to act like this model and also spin with me. So in order to make this model, all you need is a little light source. And remember, we're going to call it, this is where the sun is. And go ahead, you can stand up and use a window or a light, or you even use a computer monitor. And I'm going to make myself the planet Earth. Whenever I could see the lights on my face, I know it's daytime. And all I need to do to make it nighttime for me, or nighttime for the planet Earth, I just need to spin around. So friends, if you want to do this activity with me, all you have to do to make it nighttime for you is spin around. Let's try that again. Daytime. Nighttime. Daytime. Nighttime. Daytime. Daytime. Oh, got you there. So that's what we learned, is that the Earth rotates or spins to cause day into night. I wonder if there's any other ways that the Earth moves around respecting the sun. Let's find out. Okay, so that might cause different days, but how do we get different years? Rotates is giving us different days. Oh, it says here that we revolve around the sun. This means that we spin around the sun. We move around the sun. And that's what it means to be your birthday. It's how many times have you, being on planet Earth, spun around the sun? Let's see if we could create another model to kind of figure out how that works. This time I'm going to move my sun away. And just like what's on that screen, I think I'm going to use a hula hoop to create this model. This time, instead of being the Earth, I'm going to be the sun. And I'm going to put planet Earth, this tiny little sign right here on this hula hoop. And to get an idea of how the Earth spins around the sun to give different years, all I have to do is spin the hula hoop around. This means we rotate, we revolve, we spin around the sun to give us different years. Friends, that was a lot of fun. Go ahead. And let's go ahead and see if we could explore some more. It was really kind of cool to see the sun during the daytime, but I'm wondering what are some things that I might be able to see during the night. Let's see here. Let's go ahead and see if we could take a look. Of course, friends, we could see the moon at night. The moon is a beautiful object that comes out during the nighttime. And it's a special object because it revolves or goes around planet Earth. It's so special that there's a lot of cultures that come up with different stories about patterns that they notice about the moon, the sun, and other objects they see in the sky. One of my favorite stories comes from a tribe from the Sonora, Mexico region. And it's about why do coyotes howl at the moon? So friends, go ahead and join me and howl at the moon like a coyote. Are you ready? Oh, and it's not just a coyote. There's other things associated with the moon, like a bunny. Well, let's see if we can actually see this story. You see, one day, there was this bunny. This wonderful bunny was out prancing around the deserts around Sonora, and it was eating yuma bushes, yum, 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 yum. And it was having a great time, just eating those yum bushes. Yum, 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 yum. But there was a coyote, and the coyote was thinking to itself, I'm a little hungry, and I think I smell a rabbit. And that rabbit might make me a great rabbit stew. Where's that rabbit? Where's that rabbit? Where's that rabbit? Oh, uh-oh. I think there's a coyote. Oh, no, I'm going to run away. And the rabbit just keeps going, run away. Oh, there's the coyote. Where's the... And so what does the rabbit do? Even though the coyote is the smartest animal and the clever animal, the rabbit, it kept on running. It got really tired. And so what the rabbit decides to do is climb a ladder and goes all the way up to the moon. Friends, if you look at this screen, do you see a rabbit on the moon? Let's look at it really, really closely. Oh, there might be a pattern. Just like looking at a cloud to see if there's a pattern, then we might see a rabbit on the moon. I'm not sure if I see it, but I think it might have something to do with these dark regions right here on the sky. Keep on looking and let me know on the chat if you think you could see one. Let's look. Friends. Oh, I think I might see it now. Do you see? Well, there were the ears. There's that bunny face. And there's that big bunny body with big bunny feet and a bushy tail. Oh, that, friends, that's fantastic. I think I see a bunny on the moon. Does that look like a bunny to you? It's great. There was just one little problem. The bunny was now stuck on the moon. Uh-oh. And so the bunny, oh, it was getting really hungry, but it was afraid to go down the ladder to go back to the forest to eat those yum-yum bushes because the coyote might find it. And so the bunny asked for help. And he went to ask for help, and he found some help from the big bear. And the big bear said to the bunny, hey, bunny, I know you need to protect yourself from the coyote. That coyote is still looking for you. He calls you every night. He howls at the moon. And I just can't have it because it's disrupting my sleep. So I'll make a deal with you. You could stay on the moon for half of the month, but you need to be nice and dark. And when it's nice and dark, you can come back down and hide just like me and eat your yum-yum yuma bushes. Does that sound like a good deal? Yeah, that sounds good. That sounds good. I'm going to do that. Friends, I think that means that there might be a pattern that we see with the moon. Just like we saw on the screen, we got a full moon. And that's when the rabbit is stuck on the moon. But the moon isn't always full. It changes during the course of the month. And we could create another model for this. This time, I am noticing a pattern with my Oreos. You see, when the bunny's on the moon, I have a full moon. And so all I did was twist off my Oreos, and I see all of this white space on the moon. I can see the entire thing, and that's when there's a bunny on the moon. But when the bunny gets hungry, it starts coming down the ladder. And I noticed during later in the month, less of the moon is as bright as it used to be. Let's twist this around to make it right. And less of the moon is as bright. And so I'm just going to remove just a little bit of my white space in my Oreo, and I got a gibbous moon. And then the month keeps on going, and more of the moon gets darker and darker, and I see less of the moon. The rabbit is making its way down the ladder, and now I only see half of the moon. I'm noticing a pattern. The more the bunny goes down the ladder, the less of the moon I actually see during the course of the month. So now I only have a crescent moon. And then finally, the bunny's all the way down the ladder, and what do we get? Oh, wait, it can't be a full moon. That doesn't follow the pattern. Oh, friends, I think I might not have done the model just right. I'm going to fix it. I need to fix it. Oh, friends, I know how to fix it. Instead of having a full moon at the end of the cycle, I need to have 0 of the white frosting on this Oreo cookie. I think there's only one really good way to make sure that happens. Friends, I just made a new moon. It's a moon that doesn't appear in the nighttime sky. All the shadow is back. And then that's when the coyote starts finding the rabbit again. And so the rabbit has to climb back up, and it creates more light on the moon. And it keeps on climbing up the ladder, getting away from the coyote, and there's more light on the moon. And it keeps on climbing the ladder, getting away from the coyote, and there's more light on the moon until we have a full moon. And the rabbit lifts up the ladder, and during the full moon, what does that coyote friend do? The coyote friend howls at the moon. Do it with me now, everyone. 1, 2, 3. Ow! Ow! Oh, friends, I really, really like that story because it helps explain that there are patterns in the sky. Just like we notice a pattern between day versus night, We notice a pattern during the year as we revolve or go around the sun. We might also know a pattern in the sky with the moon. You know, this is a beautiful moon that I have on my screen that I want to share with you. I wonder what it's like. This is a picture of the moon from planet Earth, but I'm wondering what the Earth looks like from the moon. Oh, friends, look at this. This is a picture from Apollo 11 when people, astronauts, literally landed on the moon. And they took this beautiful picture of the Earth rising above the sky over the moon horizon. This is where you live. This is your home. And I notice I don't see the entire planet Earth. Just like sometimes during the month, I don't see the entire moon. It's almost like the bunny is also climbing its ladder away from the Earth as well. And I notice that the Earth is a big circle, just like the moon was a big circle. But it's not just a circle, it's a 3D circle. It's round all the way around. And that's something we call a sphere. A sphere is basically a big ball. A ball, it's like a circle, but it's like in 3D, so it's a ball. It's a sphere. You know, I don't know if every object out in space is a sphere, though. And maybe that's the next thing we need to do. Let's act like an astronomer again and do some sorting. We classify things by grouping things with similar characteristics together. And by doing that, we get a better understanding of that thing and its place in the universe. So this is a big sphere. Let's go ahead and look at all of these objects that can be found in our universe and sort and figure out which ones are a sphere and which ones aren't. I already know the moon is a sphere. And then I think the sun, that was a big circle up in the sky. But when we go around it during the course of a year, when we revolve around it, I know it's a big sphere too. Well, what's this potato thing in the middle? Well, that doesn't look like a circle at all. That doesn't look like, well, that looks like a potato. Friends, that's an asteroid. It's a big rock that circles around the sun, revolves around the sun, but it itself is not a sphere. Let's go ahead and take that one away. What about this one? This little red thing? It looks like a circle. No, I don't think. What? Oh, it's a planet. That's Mars. And of course it's a sphere. It's a big ball, just like planet Earth. Friends, I know that these rubber chickens are in the universe. They're on planet Earth, which is a part of space, but I know also that they are not a sphere. Let's go ahead and take away the rubber chickens. You see, friends, we can actually sort and classify different objects. So one thing that I know a planet needs to be is it needs to be a sphere. It needs to be a big ball. The other thing I know a planet needs to be is that it needs to revolve or go around our sun. And so all of these objects are spheres, but only a few of them actually revolve around the sun. Let's look at them and think about which ones revolve around the sun. Okay, we've got the moon. Oh, I remember this one. This was Mars, Jupiter, and the sun. Go ahead and share on chat and make your observations of which ones you think go around or revolve around the sun. I'm going to go ahead and take away one. Yeah, I know Jupiter, it's the biggest planet. And the fact they call it the biggest planet, that tells me it does go around the sun. But this other one, if you're the sun, how can you revolve around yourself? You would rotate, you would spin around yourself just like the Earth, but you can't revolve around yourself. And then I know Mars also goes around the sun. It revolves. Well, that leaves the moon. The moon does go around the sun, but it also revolves around something else. It revolves around planet Earth. So I don't think the moon is going to be a planet. Let's go ahead and take that away. That leaves Jupiter and Mars are our two planets. They are spheres or big balls that revolve or go around the sun. Now, friends, I want to share with you something extra special that's happening this month. We are going to Mars. We are sending a rocket ship all the way to the red planet. And in February, a remote control car called a rover is going to land on that planet. This is what it looks like. This is Perseverance. And it's really going to be somebody's job to drive a remote control car on another planet. This robot is going to collect rocks that one day might be sent back to planet Earth. And it's going to look for signs that life might have once lived on Mars. I'm really excited because it's this month that they are going to send the rocket ship. Blast off the rocket ship with this remote control car on top all the way to Mars. It's going to happen on July 30th. Well, look at that rocket ship. Isn't it beautiful? I wonder how this rocket ship actually works. You see, I see the rocket ship is definitely going up, and we got a lot of smoke. It's going to the left and going to the right. And I see all this fire. But which direction is that fire going? I don't know if it's going up. It seems to be going in the opposite direction. You see, friends, let's do an experiment. I was once told that in order to go one way, you have to push in the opposite direction. So if I want to go right, I have to push left. If I want to go left, I have to push right. And if I want to go up, well, the opposite of up is down. Let's go ahead and test that idea. I'm going to go ahead and jump up. You could go ahead and stand up and jump up with me. And we're going to jump up together on the count of 3. But you have to do it really, really slowly. And I want you to tell me which direction did you move first before you jumped up. Are you ready? 1, 2, 3. Friends, I went below the screen before I went up. Let's try that again. Are you ready? 1, 2, 3. Friends, in order to go up, you must push down. Well, let's try it this way. Let's try it so I don't push down or you don't push down. This means in order to jump up, I don't want you to bend your knees or push down on your feet or bend your ankles or bend anything below your shoulders, okay? And we're gonna try to jump as high as we can without pushing down by only pushing up. Are you ready? 1, 2, 3. Friends, I can't do it. I have to go in the opposite direction. And the rocket ship is the same way. In order for the rocket ship to go up, that fire and energy must push down. Well, let's create another model to see really how that might work. Friends, I got a rocket ship on a string. That is its trajectory right here. And this is going to be my tiny little rocket ship, and it is going to travel all the way up the screen, all the way, and you can't really see it, but that thing really far away is a picture of Mars. Now all I need to do is give my rocket ship the energy it needs to push all the way to Mars. And I'm going to do that with a balloon. My question for you is, which direction should I attach the balloon so that it pushes its air the opposite direction of the moon? So we're going to face this right here. I'm going to pull out the pin so I could actually launch the moon. And I'm probably going to pop it in the meantime. So, yep. Oh, friends, it's stuck. It's stuck, friends. Oh, no. Oh, there we go. All right. Now all we need to do is attach the rocket. Do you see our nozzle right there? We're going to attach this to our rocket ship, which is tied on the string. I'm going to place the camera right here so everyone can see. There we go. And friends, if I want to, oh, I was afraid that might happen. Oh, friends, let's get another balloon, okay? Now, if I want to go in one direction, I know the air needs to push in the other direction. So if I want to go that way, I don't know if the nozzle needs to blow the air that way. I think the nozzle needs to blow the air this way, the opposite direction. So I'm going to take my balloon onto my rocket ship so that nozzle is paying the opposite direction. And now, friends, let's see if we can watch our rocket go. Can everyone give me a countdown so we could travel all the way to Mars? Here we go. 3, 2, 1. Blast off. Hey, friends, we made it all the way to Mars. That's fantastic. And I want all of you to stay tuned for July 30th when NASA's going to be sending a rocket to Mars. In the meantime, I want to thank everyone for participating in this program. It was a lot of fun to be joining you and seeing the different patterns that we could observe from space. You can all help us out by helping us fill out the survey. Tell us which parts of this program you really liked. We're learning a lot more about the curriculum that we might be able to offer and students all across Washington when they go back to school or stay home for school this fall. You can also support our programs by donating. It takes a lot of resources to actually provide these programs for a lot of people. So if you go to pacsci.org/support, any little donation will help fund and provide more programming all across our state and the Pacific Northwest. We could accept anything helps from $5 to $500,000. Any donation might be great. And then finally, friends, I want you to stay curious. Go to pacsci.org/curiosity@home and join our Mercer Slew friends for a whole series of educational videos and activities that you could do at home with your early childhood learners. So thank you all for joining me. I really had a lot of fun exploring space. Thank you for your patience with my little rocket ship. I hope you take those Oreo experiments and that rocket ship experiment and you try it at home too. Thank you, everybody, for joining us. Bye.